Hey everyone, so we are in a new chapter, chapter 11, which is chemical reactions. So you're going to be able to identify reactions and classify them in certain types, whether it be single replacement, synthesis, combustion, acid-base, and you'll be able to understand that here in just a little bit. But first, before I wanted to do that, I wanted to go ahead and I wanted to introduce you to some chemical reactions we have going on here. So first things first, is I have this first reaction here. It is a single replacement reaction. What we'll have is we'll have magnesium solid, which is this guy right here. Magnesium usually comes in a nice little ribbon form. And what we'll have it mixed with is some hydrochloric acid, which just looks like regular water almost, but be careful because it is HCl, it is 6 molar, so it can irritate your skin. And what you're going to see is that magnesium solid is going to go into this HCl, and it's going to change into magnesium chloride and hydrogen. Okay, and hydrogen's form is best known as a gas. So let's go ahead and let's put these together and let's see what happens. So again, I got my HCl, I got my magnesium. Let's go ahead and put those in. So as you can see, that magnesium is reacting with that HCl and it's forming this gas, which is actually smells really bad. That's why I got my fume hood on nearby. But as you can see now, that HCl, or that magnesium, is now gone. It is completely dissolved in that HCl. And you might be thinking, oh, it just evaporated. No, it's actually floating inside of that HCl. It went in there, it dissolved, and now it's turned into magnesium chloride, which is dissolved in water and you can't really see it. And all that gas that was coming off was our hydrogen gas. So I'm going to go ahead and put this in the fume hood in case it produces any more hydrogen gas, which is flammable. So I'm going to take off that glove now that I'm done with that magnesium, which can irritate your skin. The next one we're looking at is potassium iodide and lead nitrate. And you've probably seen this reaction before or might remember this reaction. But what we have is we have two reactions. They're swapping. This K is now getting with this NO3. This lead is now getting with this iodine. And they're forming potassium nitrate, which isn't too exciting, and lead iodide, which could be a little bit more exciting. So in this big beaker, I got my lead nitrate. In this small one, I got my potassium iodide. I'm going to mix these together and you'll notice a reaction pretty early on. So that's that lead iodide. It gives off that really weird cursed orange juice kind of look. Okay, don't drink it, it's lead. But that's a cool little reaction where two clear liquids come together and form this totally, completely new, different forbidden orange juice looking drink. And now our last one we're going to look at is a combustion reaction. Whenever you see O2 on the reactant side, you're going to get a combustion reaction. And unfortunately, I didn't balance this. So let's go ahead and do that. I got 2 oxygens here, 2 oxygens there, 4 hydrogens, 4 hydrogens. So this will be a combustion reaction, which I will show you right now. Hey everyone, so here is another reaction, kind of similar to our magnesium and HCl reaction, but instead of magnesium reacting with HCl, it's zinc reacting with HCl. It's very similar, it's still single replacement. Again, it's just zinc instead of magnesium. So that zinc is reacting with that hydrochloric acid, it's kicking out that hydrogen, and it's forming hydrogen gas, which is being collected by this balloon. And once we get that hydrogen collected by that balloon enough, I'll show you one more cool reaction. Alright everybody, here's our last reaction. I now have my hydrogen balloon attached to a ring stand, and what we're going to witness here is a combustion reaction. We got hydrogen gas in there, it's going to react with the oxygen in the room, and it's going to form actually just water. But in order to do that, it's got to break some bonds, and I'm going to light it with a match on the end of the meter stick because I don't want to be close to this thing because it'll release a nice, good-sized fireball. So I'm going to, I know it looks like this is really close to the balloon, but it's not. So I'm going to stand over here. I'm going to do my best to light this on the first try. Bear with me, and we'll see if we get a nice, cool little explosion. Again, bear with me. It's hard to light a match that's attached to a meter stick. Alright, here we go. Woo! Okay, so that was a big explosion thanks to the hydrogen gas. If you guys have seen the Hindenburg, it also exploded because it was filled with hydrogen gas. So that was just a little balloon. So imagine if you have a blimp's worth of hydrogen gas. Imagine how big that explosion had to be. So hopefully you enjoyed those reactions. Now let's get into classifying those reactions. So we're going to be dealing with 7 types today. We're going to be dealing with synthesis, decomposition, single replacement, double replacement, combustion, precipitation, and acid base. And you'll be able to identify those in no time. So let's focus on our first one of synthesis. Synthesis reaction. You might be able to guess what happens in a synthesis reaction. The only thing that is happening is that 2 compounds or 2 reactants are going to come together and they're going to form one product. So it's 2 things becoming one. You could kind of guess that with synthesis, right? That's kind of the word that means 2 things combining or 2 things joining together. A good example, these aren't real elements, they're just placeholder for elements, but a real world example of this is if we have something like calcium oxide reacting with water. Those are 2 separate compounds, but once they react with one another, they will go ahead and form calcium hydroxide. So that is a good real-world example of a synthesis reaction. Our next type of reaction is actually the exact opposite of this, and it is known as decomposition. So now, instead of 2 things joining together, like you would see, oh, that looks awful, like you would see in a synthesis reaction, you're going to have one thing becoming 2 things. So a compound's going to break up, a reactant is going to break up into 2 separate products. A good example of this is something like water. When it decomposes, it could decompose into hydrogen gas and oxygen gas. And you guys might be wondering, what are these little parenthesis things here at the bottom? Well, I'll explain that in just a second. Another good example of this is something like calcium carbonate. Alright, it could decompose into calcium oxide and carbon dioxide. So this is a decomposition reaction. We have 2 compounds or 2 reactants on the left side breaking down into 2 different products. They're splitting apart, they're decomposing. So let's talk about these things in parentheses. I have a parenthesis cursive L, a parenthesis G, and a parenthesis S. Those are all things that you see. All that is, and you could probably guess that, is they're the states of those compounds. They're what type of state of matter they're in. So if you have a parenthesis S next to something like calcium carbonate, that's just telling you it's a solid. It's in its solid form. It's not melted in its liquid form, and it's not evaporated into its gaseous form. We also have L here. That's going to stand for liquid. And then as you can see underneath our hydrogen and oxygen, we have gases. And there's one more you're going to see, and it is AQ, which stands for aqueous. I think I spelled that right, aqueous. And all aqueous is it's a solid dissolved in a liquid. So when I showed you that single replacement reaction and I put that magnesium in there and I said it dissolved in there and became magnesium chloride, that was an aqueous solution. If you put salt and water, that is an aqueous solution. That's a solid dissolved in a liquid, okay? You can't see the solid, but those little tiny particles are floating in there, and that's what we call aqueous. Let's get moving on to our next classification. So we've talked about synthesis, we've talked about decomposition, and now we are going to talk about single replacement. So we're going to have single replacement, which is going to be some form of A plus BX is going to equal B plus AX. And all it is that one element is going to come in and kick out another. As you can see, A was by itself, B and X were together. Well, A decided to swap places with B, and now B is by itself, and AX are now together. And that is a single replacement reaction. A good example of this, you see this a lot with metals, but a good example of this is magnesium reacting with copper sulfate. Magnesium's a positive ion, copper's a positive ion. They're going to swap places. So now instead of magnesium being by itself, we're going to have copper by itself. And now magnesium is going to form with that sulfate ion to form magnesium sulfate. So that's a single replacement. Just one guy's going in, kicking out the other. Let's talk about another, and that was what we saw when I put that magnesium and that hydrochloric acid, right? It became magnesium chloride, and that hydrogen got kicked out. So let's talk about not just single replacement, let's talk about our fourth classification, which is now double replacement. Double replacement. And double replacement, instead of one thing getting swapped out, now you're just going to have two things swapping each other out. So the layout for this is AX plus BY equals AY plus BX. And an example of this in the real world is going to be something like sodium sulfide reacting with hydrochloric acid. So what you have here is you have two compounds. Remember that sodium is a positive ion, sulfur is a negative ion, hydrogen's a positive ion, and chlorine is a negative ion. And they are going to swap partners with one another. When they swap, the sodium's not going to go with the hydrogen because they're both positive. The sodium is going to go with the chlorine, and it's going to become NaCl. Same deal here. Sulfur is not going to go with the chlorine because they're both negative. Sulfur is going to go with the hydrogen and form H2S because we got to balance those charges, right? So this is a double replacement. You have two compounds on the left side and they just swap. That Na went with the Cl, the H went with the S, and they made our two completely different compounds of NaCl and H2S. So we have now covered 4 of synthesis, 2 things coming together, decomposition, 1 thing breaking apart, single replacement, 1 guy going in and kicking out another element, double replacement, 2 compounds swapping their partners and making 2 totally different compounds. I've now cleaned up the board a little bit to go on to our next one, which is known as combustion. It is the fun one, the one where things go boom. Okay, to identify a combustion reaction, there has to be O2 on the reactant side, so on the left side. So, has to have O2 on the reactant side. We saw that with that cool hydrogen balloon explosion where it was hydrogen and oxygen forming H2O. When balanced, looks like that, right? We had O2 on the reactant side. If you ever see O2 on the left, automatically it's combustion. But now that I'm looking at that, what other classification can that reaction be? It's not just combustion, it can be more than one. Alright, you can have a reaction be up to 3 classifications. So this one right here is combustion, and it is also synthesis. 2 things coming together to form that H2O. So that's also synthesis. But of course we see that oxygen on the left side, it's going to be a combustion. Let me tell you about combustion reactions that deal with hydrocarbons. Okay? This is a hydrocarbon. A hydrocarbon is anything with a CH4. That could be C2H6, it could be C3H8, it could be C10H, I think it'd be 26. Okay? Anything that just has carbon and hydrogen is known as a hydrocarbon. Well, if you have a reaction where you have an O2 mixing with a hydrocarbon, it's going to form the same thing always. It's going to form the same 2 products, which are CO2 and H2O. I don't care if it's C3H8 plus O2. I don't care if it's that C10H26 plus O2 that I just talked about. they are always going to form CO2 and H2O whenever an oxygen is mixing with a hydrocarbon. The only thing that might change is that you might get different amounts of H2O and different amounts of CO2. Like here, I'll have 2 waters and I'll need 2 oxygens to make it happen. For this one, I'm going to produce 3 carbon dioxides and 4 waters, and then I'll get 5 oxygens needed. And I don't even want to balance that one. But you get the point, right? Products are going to be the same. You're just going to have different amounts of them. Let's talk about, so that's 5. We got 2 more. That's 5. We got 2 more. Let's talk about, this horrible dry erase board that is too old and might need to be retired soon. We'll give it a proper send-off. We'll put it on a Viking ship. We'll shoot a flaming arrow at the Viking ship. And that'll be that. I don't even know if this will melt or catch on fire. But anyway, 6th one is called precipitation. A precipitation reaction. And you might be thinking, rain, right? Precipitation's got to do something with water. Well, precipitation just means something is created. In terms of rain, rain is being created, liquid is being created. But in our chemistry class, precipitation to us means that there is going to be a precipitate made. A precipitate. And you might be like, what the heck is a precipitate? A precipitate is a solid formed from mixing 2 aqueous solutions. So we observed this when I mixed that potassium nitrate and that lead iodide together and made that orange liquid. Okay, that was a precipitate reaction. I mixed those 2 aqueous solutions together and they made that yellow solid that was potassium or lead iodide. Sorry, it looked liquidy, but it was actually just a bunch of really tiny solid particles that mixed together to make that weird yellow color. So when we see a reaction that give us states like aqueous, we are going to be looking into that and asking ourselves, is this a precipitation reaction or not? Well, if I look at this, I got potassium carbonate and barium chloride coming together, and they are going to make barium carbonate, which is a solid. This is a precipitation reaction. We have 2 aqueous solutions coming together, and they form a solid precipitate on the product side. What else could this be classification-wise? You are going to see that some of these have common similarities, okay, if that's not redundant. But here you could see that they actually swapped partners, right? The Cl went with the K, the CO3 went with the Ba. This is also a double replacement reaction. Pretty much most precipitation reactions are also double replacement reactions. So 2 aqueous solutions coming together, making a solid, that is a precipitate. And last but not least, before I have to clean this board again, our last one is acid-base. Acid-base. First, we gotta know what an acid and what a base is. We can identify an acid pretty easily, right? An acid starts with an H. We know that from our naming lessons. But what about a base? How do we identify if it's a base or not? A base is anything that ends with OH. So an acid-base reaction has to have both. It has to have acid and it has to have a base. An example of this is HCl mixing with NaOH. We got an acid and we got a base here. Now our acid-base reactions are always going to form one product that is always the same, and that is H2O and then it'll form its salt, which is NaCl. So whenever you see an acid-base reaction, so if you ever see something with an H and something that ends with an OH, when they react, one of your products is always going to be water. Water will always be formed, and that always comes from the H and the OH in our acid-base reaction. And then the second product is going to be a salt, which is just Na and Cl. Now you might be saying, salt, that's just NaCl. A salt is anything that's got like an alkali metal or alkaline earth metal. So calcium sulfate is a salt. Okay, sodium fluoride is technically a salt. Okay, so whenever I say salt, think broader. Think of more than just NaCl. So this is acid-base. What else could it be? It could also be double replacement again, right? H and OH come together, Na and Cl come together, double replacement. Let's go ahead and let's get some examples going, and then we'll be done for the day. Alright, here's our last examples. Let's look at this first one and let's classify each of these as either synthesis, decomposition, single replacement, double replacement, combustion, acid-base, or precipitation. Okay, maybe not in that order that we went through them, but those 7. So I'm looking at this first one. What do you think the classification of this reaction is? Well, I'm looking at this and I see something's by itself, and it looks like it came in and kicked out something else, just one thing, which tells me that this guy is single replacement. And I'm just going to put SR. Feel free to put SR on your worksheets or your practice. Okay, DR for double replacement, C for combustion. All right, things like that. Let's look at this next one. So I'm looking at this one down here, and right off the bat, I gotta be saying, I think I know what this is. I identify one thing that tells me what this is. So, what do you think this is? Well, I'm looking at it, and I see that O2 is on the left side. If O2 is on the reactant side, it is going to be combustion. Combustion. So, we're looking at this C. What do we think this is? A common mistake that you guys are going to make is you're going to say O2, it's combustion. It's not. O2 has to be on the reactant side. All right, if it's on the product side, it's not combustion. So I'm looking at this, I see that we got our little friend of hydrogen peroxide here, and it is one thing, and now it has broken down into 2 things. That makes this a decomposition reaction. Or as I like to say, decomp. Right, I'm cool, I'm hip, I can shorten words. Right, bro. Alright, so anyway, we're looking at this last one. I see I got 2 compounds, they're coming together making 2 new compounds. So I'm going to be saying like, hey, this looks like they're swapping partners. We got H going with this OH, we got S going with this barium here. I'm saying that this is double replacement. But some of you might be saying, whoa, Mr. Dahmer, whoa. This also is another classification. We got an acid here, we got a base here, right? Starts with H, ends with OH, and it made water, so this is also a acid-base reaction. And some of you might be saying, whoa, Mr. Dahmer, this is also a precipitation reaction. We got 2 aqueous solutions, they come together, they form a solid, they form a precipitate, so this is also a precipitation reaction, or a precip, or you can just put P, whatever, doesn't matter to me. So this is classifying reactions. This is the main thing you're doing. Okay, get used to it. Get used to noticing the patterns and being able to identify these guys. That's it, everybody. Have yourself a great day. Let me know if you have any questions.